This demonstration will go through flow selection and how it can be used for dedicated machines versus multipurpose machines. Okay, let's start with a model overview. We have three variants: Part A, Part B, and Part C. They are produced in these sources and stored here. We have three operations, and we want to evaluate two cases. The first being that each of the machines are dedicated to one variant. A for Part A, Operation B for Part B, and Operation C for Part C. The other case will be that they can process any of these parts. The difference being that when they can process all parts, there will be setup times in between, and we have that here. You can see that it's 30 minutes setup between A and B, and between A and C it's 1 hour, and so on. And the processing time is set to 1 hour for this object. Okay, so let's use flow selection to model these two cases. We start by selecting the root flows. In that we add a selection, and in that group that will contain three flows. This group is for the dedicated machines, and we need to have a group in order to be able to select these three flows as one option. So let's rename this as dedicated machines, and the other option within the selection would be multipurpose machines. So let's add that flow and rename it. We rename these flows as flow A for Part A, flow B for Part B, and finally C. Okay. Now we need to add variants to these flows. A to A, B to B, and C over here. And for the multipurpose case, we will add all three variants. Now we need to add connections to the flows. So let's set this one as the current one. And for that flow, Part A will go to Operation A. Here, Part B to B. And C to Operation C. And finally, the multipurpose machine case, we send the variants to all machines. Now, if we select this, we see that we have this active num as one setting, and that is what decides which of the flows that is active. Here you have dedicated machines and multipurpose machines as options. And it's easy to switch which one is the active one. Okay, now let's see how we can use this flow selection to evaluate dedicated machines versus multipurpose machines. But before we do that, we need to make this a bit more realistic by adding some disturbances to this object. So let's set the availability to 80% and the mean time to repair to 30 minutes. Okay. So we start with a case with dedicated machines, and we take a look at that in the animation. Let's speed things up a bit. You can see A goes to A, and B to B, and C to C. Okay. And we go back, and instead we test the multipurpose case. Start here. A, B, C. That's the case here. You see, they start switching places. Now let's take a look at what this means when we run a tie-in simulation. Again, we start with dedicated machines, and we start an experiment. So what is our throughput? 2.4 parts per hour, and our utilization is around 80%, as we expected. And we have no setup for the machines. So we go back, we select multipurpose machines, we run another experiment. Now our throughput went down to 1.7 parts per hour, and the utilization, we can see that we have a lot of setup time in the model. We lose production capacity due to these setups. So for this particular configuration, it is better to go with dedicated machines. To summarize, in this demonstration, we have looked at flow selections and what it means to have dedicated machines versus multi-purpose machines when you have setups in your model. And for this test case, it turned out that dedicated machines produced a lot more parts. Thanks for watching.